The process of splitting a dataset into training and test subsets is a critical step in building and evaluating machine learning models. Training data serves as the foundation for model development, enabling the algorithm to learn patterns, relationships, and features within the data. Test data, on the other hand, acts as an independent benchmark to assess how well the trained model generalizes to unseen data. Striking the right balance between these subsets is essential to ensure accurate and reliable model evaluation. An effective split typically involves allocating a larger portion of the data to training, commonly 70 to 80%, while reserving the remaining 20 to 30% for testing. This ensures the model has sufficient information to learn effectively while maintaining a robust evaluation framework. However, the split ratio may vary depending on the size and nature of the dataset. For smaller datasets, techniques like cross-validation can be employed to maximize the utility of limited data, allowing the model to be tested across multiple folds. It is also important to ensure that both the training and test sets are representative of the overall dataset. Random sampling is often used to achieve this, minimizing the risk of bias in the split. In cases where the dataset contains imbalanced classes or time series data, stratified sampling or temporal considerations may be necessary to preserve the integrity of the split. Failing to account for these nuances can lead to inaccurate evaluations and misleading performance metrics. Another key consideration is avoiding data leakage, which occurs when information from the test set inadvertently influences the training process. Data leakage can significantly inflate performance metrics, creating a false sense of model effectiveness. To prevent this, any pre-processing steps, such as normalization or feature engineering, should be applied separately to the training and test sets. Additionally, when working with time series data, chronological order must be maintained to ensure the test set simulates future predictions. Ultimately, the goal of splitting the dataset is to create a reliable framework for assessing the model's ability to generalize to new data. By carefully considering the split ratio, sampling methods, and potential pitfalls like data leakage, practitioners can build models that perform well not only on the test data, but also in real-world applications. A thoughtful approach to training and test data division lays the groundwork for robust and trustworthy machine learning solutions.